The posterior teeth were arranged along the curvature, staying within the found line, not crossing it. Although the central grooves may look slightly off when viewed from above, this level of variation is completely acceptable, and you can finish the posterior arrangement as it is without any problem. And this is how it looks from the frontal view. By using a arrangement accessory, I was able to incorporate the proper curvature easily and accurately without being affected by any visual illusion or optical bias. This method allows anyone to achieve consistent and precise curvature during setup. Now coming back, once the maxillary cast is mounted, simply arrange the remaining maxillary posterior teeth to match the mandibular setup. During gingival contouring, we create a concave surface from the cervical area of the mandibular anteriors down to the borders. This design ensures that the dentures does not interfere with the muscle. It is crucial to maintain this specific contour during the finishing and polishing stage after curing. The purpose of this concave shape is to prevent the lower lip from pushing the denture backward, which could lead to dislodgement and to significantly reduce any foreign body sensation for the patient. The final finishing was completed using a composite resin called Excel Nexco. Is Ivoclar product. Of course, it must be shaped concavely. The lingual surface of the mandibular denture should also be shaped concavely in the posterior area to ensure enough tongue space. Sometimes when patients try on new dentures, they say things like, it feels like my whole mouth is filled. The dentures feels too big. While such reaction can result from an increased vertical dimension, there are often caused by insufficient tongue space on the lingual side as well. This is how it looks when set inside the mouth. This result was achieved by allowing the patient to stay relaxed so that the anterior teeth becomes slightly more visible in a natural resting position. This is the facial view of the patient's broad smile. Notice the idle smile line here. We aim for a simple setup by using model indicators instead of a wax rim. This has been our analog method for making aesthetic dentures with the JB tray. Next, I'll introduce how we can take these analog principles and apply them to digital workflows using scan data. Uh, uh, After taking the JB tray impression, we perform a scan for digital processing uh, model scan data scanner here. But in a clinical setting, you can certainly an intramoral scanner instead. This is stage where we form the border of the distal model. Much like the boxing process for a gypsum model, you should set up extension to be approximately 2 millimeter beyond the border edge. Same two methods though, on the lower denture. Repeat the same process for both the upper and lower. With this, the digital model creation is finished. First, I will carve the post them just as I would in the analog process. I'm designing it based on Swenson methods, carving the digital surface as if I were scraping the gypsum model. While there are various designs for the first dam, in my experience, Swanson's design has consistently shown the highest success rate for achieving a reliable posterior apparatus seal. This exact same workflow as in analog mounting, where we position the model on top of the JD device. I'm simply applying the same logic here in the digital environment. By referencing the horizontal and vertical planes of the scanned pupil, I align the midpoint of the maxillary median parietal lip and the parietal fovea with the reference median line on the screen. I also refer to the posterior part of the impression to establish the horizontal reference. Now we are at the stage of the defining the digital borderlines for the denture. To perfectly replicate the length and thickness of the rubber-based impression in a digital format, you must draw the borderline approximately 2 to 3 millimeters beyond the deepest part of the border. Otherwise, the digital dentures will end up much shorter and thinner than intended. This is why following this specific border logic is so important. Just follow the same steps for both the maxilla and the mandible. In the case of the mandible, the thickness of the sublingual fold is extremely important. Therefore, you should draw the borderline very wide at this stage. This makes it much easier to adjust the thickness during the late steps. During the artificial tooth arrangement stage, you can follow the same analog standards and sequence that you are already familiar with. The sequence begin with setting the height of the maxillary anteriors, followed by the arrangement of the mandibular anteriors, then the mandibular posteriors, and finally the maxillary posteriors. At this stage, I am focusing on adjusting the border thickness and gingival contouring. Since the process is quite intuitive and doesn't require a lot of explanation, I let you simply enjoy watching the digital scraping for a moment. For all my digital design work, using a drawing tablet like this is an absolute must. This is Wacom tablet. Designing with a mouse for long hours causes a lot of strain on my wrist and index finger. Plus, it's quite difficult to achieve precise drawings using just a mouse. However, using a drawing tablet like this feels just like sketching by hand because it makes the design process so intuitive. You can work much faster and with more ease. I highly recommended this system to all of you. This is denture fabricated using Ivy-class Evotion milling disc, two tones blocks. We also frequently use a method where the stays the same, but we print the base and the teeth separately. After printing, we simply assemble and bond them to complete the denture. While this method offers a very shorter processing time and allows for high volume production, making it extremely efficient. However, since occlusion discrepancies can occur when bonding the separately printed base and teeth, a certain amount of occlusion adjustment is necessary after the assembly process. To bond the teeth and the base, I use the same 3D printing based denture based resin and then perform light curing for a secure attachment. It has its trade-offs, but in my practice, I find this technique most effective for temporary denture. Now, returning to our main case, let's proceed with the milling process for this denture. Because it's a one-piece design, we don't have to worry about any occlusal discrepancies during assembly. This eliminates the need for extra adjustments, greatly streamlining the final workflow. As this is the definitive prosthesis, I've applied aesthetic composite resin to enhance the gingival details and overall aesthetics. As you can see, we were able to achieve successful clinical result, both in terms of functional and aesthetics. One visit, complete denture. If you can accurately record both the impression and the particular dimension using the JB tray, it is possible to easily fabricate high quality dentures through the streamlined one step workflow. I'd like to show you the denture made with the 3D printing material I mentioned earlier. This is a printed replica of temporary dentures, although it was created from precision impression. Uh, you can view it as if it were captured using a JB tray. Uh, the material used is Ivo-class evolution-based print. I use it frequently because of its excellent strength and high productivity. The process is identical to the previous design steps. Please take another look. First, we define the digital model lines. Next, we create the post dam applying Swen's technique, of course. Mm. We then set the borderlines and thickness on the model. Deepest borderline to 2 to 3 millimeter. Since a certain degree of undercut is beneficial for denture retention, I'm removing all the blowout areas. And tooth arrangement standards we discussed in theory are now being reproduced exactly in the digital environment. Anterior six and then posterior, lower posterior, and upper posterior teeth arrangement. Mm. I also simulate lateral movement in CAD and trim any interfering spots just once or twice, not extensively. gingival contour is done. Once the design is complete, you can proceed with the cam nesting using Ashiga Composer. At this stage, I usually set the articulator to print at the same time. After printing, we go through the washing process. For the final light curing, we use the denture-based resin as a bonding agent to join the artificial tooth and then cure them together. Using an acrylic resin like Probase also works very well for bonding the teeth. Both the methods are effective, so you can choose whichever is more convenient for your workflow. To address any discrepancies that may occur after bonding the teeth, I use the printed digital articulate for final adjustment. By setting a 0.2 millimeter offset for the tooth pocket, the occlusion doesn't end up significantly high, therefore, only a couple of light spot grind are usually enough. Since I already simulated the lateral movements in 3-shaft, there were no major interference to deal with. I completed the final finish with XR Nexco. After finishing the fabrication, I verified the final fit. Both the maxillary and mandibular retention were excellent, and occlusion was quite satisfactory. I scanned the intaglio surface after printing and merged it with the original design for analysis. While traditional resins used in analog denture fabrication tend to shrink and causes deformation. 3D printed dentures clearly exhibit much less shrinkage. I believe this dimensional stability is the reason for the superior retention compared to conventional analog method. When tried in the mouse, it's honestly hard to tell whether it was made through analog or digital method. The entire workflow, scanning, design, printing, washing, curing, and polishing, took exactly 24 hours. I received the case around noon, scanned and designed it immediately, and started the print. By the second morning, I bonded the teeth and finished the SR Nexco characterization and polishing before lunch, leading to delivery the very next day. It is incredibly streamlined and convenient. It was the same process here. I received the scan files for this case after the clinician took the impressions using the JB tray. The overlook workflow remains the same. First, fill out the order form, then started the design. I always using a evolution module, iVocla product. You should set the plane based on the JB trace purple and draw the border lines to generate the digital model. Uh, mm, I also made sure not to overlook the post dam, fabricating it according to the Swen's method. my routine. We apply the same criteria for both the borderlines and the tooth setup. Please enjoy the demonstration. Mm. While the gingival contouring is the same, I'll be using Arum A7 milling machine to perform a two-step milling system for this patient. Uh, we found that integrated disc-like evolution had issues with resin durability and tooth wear. To improve upon that, we are using this compensation method. First, we build the teeth using a high-strength material and build the base with a specific pocket. Once they are bonded with acrylic resin, we run the CAM software again for the combined until and do a final milling. This not only increases durability but also results in a much more natural and aesthetic look due to the clear separation between the teeth and the gingiva. Arum dentistry is lollipop, even the deep undercut were milled perfectly, processing undercut on the inner surface of an upper dentures has always been the ultimate weakness of milling systems. So seeing this was absolutely fantastic. This is real patient danger for the live demonstration session with Professor He scheduled for in Mongolia. Local dentist in Mongolia provided the scan files after taking the impressions. And I've completed the denture using those files. We will have to wait until next week to see the final outcome. But I'm anticipating very high retention and a very highly aesthetics result. That concludes my lectures on the JB Tray on a new system for denture fabrication. I hope you enjoyed it. Due to the limited time, I had to omit much of the detail regarding artificial tooth arrangement and occlusion part. But I'm glad I could at least introduce this new system to you. I look forward to having another opportunity like this in the future. If you have any questions, feel free to reach out via social media anytime. Thank you for bearing with my unpolished first English lectures. See you again. Thank you.
Thank you very much for the presentation, Mr. Zhang. Very good. Yeah, today our webinar is finished. We hope that today's webinars provide useful insight to your guys into the digital denture workflow using JB Tray and JB Fork. And I would like to express our sincere appreciation to Professor He and Mr. Zhang for sharing their valuable knowledge and experience with us today. We'd also like to thank for all the participants who join us from the different countries, many peoples. Your interest and participation made this webinar truly meaningful.
Dr. Lee, I'm sorry. So,
Yep.
이 질문 하나를 답변해 줘야 될 것 같은데, 아까 내가 물어본. 장 소장님, 엑소캐드를 쓰고 있는 유저가
네.
엑소캐드로 디자인하거나 했을 때 뭔가 어려움이 있었는지, 3쉐입으로 꼭 해야 되는 건지, 또 엑소캐드를 썼을 때 어떤 장점이 있는지, 3쉐입으로 어떤 장점이 있는지 이런 걸 답변을 해주시면 어떨까 싶은데요. 여기 지금 질문이 올라와가지고 챗박스에.
그런데 제가 엑소캐드를 덴처로 해본 적은 없어가지고 제가 비교를 할 수는 없을 것 같아요.
I asked to him what he think about using the ExoCAD for design the denture. So unluckily he didn't have any experience to design using ExoCAD. So is it answer? So anyway, 가능은 하죠?
예, 가능하죠.
Yeah. He said it is definitely possible to make denture and design the denture using the ExoCAD as well. So if you have any experience about designing using the ExoCAD, so next same webinar, yes. So please send the message and then give us very good information. Thank you very much. 네, 감사합니다.
Yeah. Last. Actually, I will notice one more. The new information will be uploaded to the YouTube and Instagram channels. Please stay connected with us for future webinars and education program. You can see, you can check this our SNS, and also there are where to buy the JB Tray and JB Pork. We have a global dealers, distributors, and if there is no official distributor in your country, and directly contact in the PNU the export team. And also you can check the QR link. You can check the order sheet in here and ask the email anytime there. Once again, thank you very much for joining us today. And there is some other mentions for Professor or Mr. Zhang. Do you have
Thank you.
any?
Thank you very much. Bye.
Yeah, have a wonderful day, and we hope to see you again our next webinar. Thank you for everyone. Thank you.
See you.
See you. Bye.